Determine whether figure B is a scale drawing of figure A. I'm going to show you how to do this in problem 3, and then you can come back to problems 1 and 2 to finish those independently. So we're looking for side lengths that are paired up. So the longest side needs to go with the longest side. And the way that we determine if it's a scale drawing is we have to divide. And we typically divide the new by the original. So if we're looking for figure B, the original would be figure A. And this is how we would determine what the scale factor is. The smallest side in this one is 5, and the smallest side in this one is 2.5. The medium side length is paired up with the medium side length. And to determine if it's a scale drawing, all of these scale factors have to come out to the same value. Well, 8 divided by 4 is 2. 5 divided by 2.5 is 2. And 10.5 divided by 5.25 is also 2. So yes, in this case, figure B is a scale drawing. If just one of these numbers did not come out to the same value, then we would say it is not a scale drawing. All of the side lengths must be scaled by the same scale factor in order for it to be a scale drawing. If one of them doesn't match, it is not a scale drawing. So go back and compare figure A and B in problems 1 and 2. What do you notice and what do you wonder about these circles? You might notice that they're different colors, or different sizes, or that they all have the same center. These are considered concentric circles. It appears that the space between the inner circles is the same. You can see the space here and the space here matches. They're all the same shape, but they are different sizes. Do you think that all the circles are scale drawings of each other? You could consider the blue one an enlargement of the smaller two, or the green as a reduction of the larger two. We're going to begin by looking at parts of a cube. What parts of a cube are two-dimensional? Well, the faces, like we were using for surface area in earlier lessons, are two-dimensional. How can you describe a cross-section of figure A? Remember when we were slicing the solids using a plane? What types of cross-sections would you get from figure A? If we made a slice or a cross-section that is parallel to the base, we would get a square. And we would also get a square from figure B if we created a slice that is parallel to the base. Like you see here in problem 1. It says figure A and figure B are cubes, each with a cross-section shown. The cross-section in each figure is the result of an intersecting the cube with a plane parallel to its bases. Sketch each cross-section and label the side lengths with the appropriate measurements. Well, we have two squares. one from figure A, which is 6 inches by 6 inches. And then we also have one from figure B, which is a 2 by 2. Is the cross-section in figure B a scale drawing of the cross-section in figure A? Why? Well, yes, because if we divided 2 divided by 6 is going to work for both of those sets of side lengths, or all four, because this is a 2 and a 2 and a 6 and a 6, and that's a scale factor of 1/3. Is the cross-section in figure A scale drawing of the cross-section in figure B? Why? So now we're starting with figure B as the original and figure A as the new. So we're going to go the other way. The cross-section of the right rectangular prism is the result of intersecting the prism with a plane parallel to its bases. A base of the right rectangular prism is drawn. Sketch the cross-section on the grid. By cutting parallel to the base, you create a cross-section that is identical to the base. Is the cross-section a scale drawing of one of its bases? If so, what is the scale factor? And if not, explain. It is, and the scale factor when you create identical shapes is 1. Seven divided by 7 is 1. 4 divided by 4 is 1. So the scale factor in this case is 1. The cross-section of the right rectangular prism is the result of the intersecting the prism with a plane perpendicular to its bases and parallel to two of its faces. A base of the right rectangular prism is drawn. Sketch the cross-section. Well, it's 2 across and 5 tall. Is the cross-section a scale drawing of one of its bases? If so, explain why and determine the scale factor. If not, explain why not. Well, these side lengths here five divided by 2 would be at 2.5. And then these here, 2 divided by 2 would be 1. Those are not the same. It is not stretched or shrunk in the same way in both directions. So this is not a scale drawing. The cross-section of the right triangular prism is the result of intersecting the prism with a plane parallel to its bases. A base of the right triangular prism is drawn. Sketch the cross-section on the grid. This is 4 by 3. And the original was 4 by 3 as well. So yes, this one does have a scale factor of 1. Four divided by 4 is 1. 3 divided by 3 is 1. They both came out the same, so it is a scale drawing. The cross-section of the right triangular prism is the result of intersecting the prism with a plane perpendicular to its bases and parallel to one of its faces. A base of the right triangular prism is drawn. Sketch the cross-section on the grid. This is 1 across and 6 tall. These cannot be scale drawings of one another because this one is a triangle and this is a rectangle. The cross-section of the right square pyramid is the result of intersecting the pyramid with a plane parallel to its base. The base of the square pyramid is drawn. Sketch the cross-section on the grid. So I have a 1 by 1 square. And this was a 5 by 5 square. Is the cross-section a scale drawing of one of its bases? If so, determine the scale factor. Yes, it is. 1 divided by 5 is 1/5, and it works for both sets of sides. We divide the new by the original. The cross-section of the right rectangular pyramid is the result of intersecting the pyramid with a plane parallel to its base. The base of the right rectangular pyramid is drawn. Sketch the cross-section on the grid. I have a 1 by 3. The original was a 2 by 6. Is the cross-section a scale factor? If so, determine the scale factor. The new length is 3. The original was 6, which reduces to 1/2. This side was 1, and it is paired up with the side length of 2. 1 divided by 2 is also 1/2. So yes, this is a scale drawing, and the scale factor is 1/2. For problems 8 and 9, the cross-section is the result of intersecting a right pyramid with a plane parallel to its base. Write an equation in the form a over b equals c over d to solve for x. Determine the unknown side length. So I'm going to show that the corresponding sides would be 9 and 36. Those are both like the width here, and that will create one fraction. And then I'm also going to show that this side length here corresponds with the 100. I put the small ones both on the tops of my fractions and the large ones both on the bottom of my fractions. This is because this is a reduction. If it was an enlargement, we might switch those. But we want to make sure that if I put the small one on the top here, the small one goes on the top here as well. We wouldn't want to put it on the bottom because that would mess up how they are corresponding. Now, if we were to solve this for x, right now x is being divided by 100. So to undo that, I need to multiply by 100. This would be 100x over 100, because remember there's an invisible 1 there. And then this side would be 900 over 36. Now we can simplify those fractions. 100x divided by 100 is just a single x, and 900 divided by 36 is 25. So x is 25, which means the unknown side length is 25 centimeters. Here, the 29 and the 100 get paired up together. And the x and the 60 get paired up together. X is being divided by 60, so we're going to multiply by 60 on both sides to undo that. Sixty times x is 60x. 60 times 1 is 60. 60 times 29 is 1,740. And 1 times 100 is 100. 60x divided by 60 is x. And 1,740 divided by 100 is 17.4. So this is 17.4 inches for that missing side length. That is the end of Module 5, Lesson 1. Lesson 2 should be posted here soon.